Hello and welcome to the first episode of New Azure's live show, Mert to the Future. I am very excited to be here today and many thanks to all Azure's live team. On this show, myself and my guests will be deep diving into Azure and all related topic, which means lots of stuff with lots of demos. Today, Rick VD Bosch is with us and we will talk about Azure functions. Hi Rick, how are you? Welcome.
Well, thank you, and thanks for having me. I'm fine. How are you? I'm really looking forward to this stream today. As you said, we will be diving into Azure Functions, which is something that I really love and enjoy because serverless, I think, is the cloud platform or the cloud way of the future. So I'm looking forward to today.
Okay, I am very excited, as I said. Thank you very much. So before we start, can you please introduce yourself?
Yeah, sure. So I'm Rick VD Bosch, as you said, or in Dutch, Rick van den Bos, but that's horrible to pronounce. So we'll just do Rick. So if you want to look me up, you do Rick VD Bosch, and then you'll probably find me with DuckDuckGo or Google or Bing. I've been doing software now for more than 20 years, and I've entered the Azure realm as soon as Microsoft introduced it into the market. And since then, I have helped companies define their migration strategy towards the cloud or help companies build their cloud native applications. And because I like doing this kind of stuff, talking to people and sharing the knowledge, Microsoft has granted me the honor of being an MVP now for Microsoft Azure, so that's nice. And this is actually my first time on a live stream, so I was planning to do this earlier for myself, but then this came along, this awesome option to be on this Azure's live show. So I am going to move house in the near future, and then after that, I will be going to go stream on my own channel. But for now, let's do it over here with you, Mert.
Okay, thank you. So before we dive into the demos, I want to ask about some stuff because sometimes people confuse these terms. For example, Azure Functions, Azure Logic Apps, or Azure App Service Web Jobs. They sound similar, but as you know, they are different stuff. So can you please tell the differences when we should use Azure Functions or Logic Apps or Azure App Service Web Jobs?
Yeah, so if we look at, I'm going to do even one step further back. So Microsoft introduced Microsoft Flow some time ago, which was actually something that looked a lot like if this then that, or any other platform that enabled you to automate a certain flow. So that's why Microsoft called it Microsoft Flow. And then now they have Power Platform, which entails a lot of different technologies. And one of the technologies it has is Microsoft Power Automate, which is actually what used to be called Microsoft Flow. And then if you look at Microsoft Power Automate, that's actually a business user tool that enables you to connect things. So for instance, if somebody posts a tweet with the hashtag serverless, then you can automatically throw it into a cognitive service that does sentiment analysis on the text. And then when it's very positive, you could, for instance, create a new record in Dynamics. So you can connect all different types of systems together based on specific events. Now that's Power Automate, and as I said, that's part of Microsoft Power Platform. And then we have Logic Apps, which is essentially the same, but then in the Azure portal. So with Logic Apps, you have the ability of using more than 200 different types of connectors to connect to systems like Dynamics, but also GitHub or MailChimp or SendGrid. And then you can have some logic in there that you visually design, and you could have some outcome or multiple outcomes. So Logic Apps are a very relatively easy way of automating workflows. And where Power Automate is primarily targeted at the business user, Azure Logic Apps is primarily targeting developers. Because with Logic Apps, you also have more possibility of doing stuff like source code control or build pipelines or release pipelines for your Logic Apps. But logic apps, in the end, is all visually designed, and it gives you an XML file that has the structure of your logic app, but you can't write code yourself. You configure what the different connectors and different types of steps should do. And then if you need more control over what happens, or if you need to write custom code, then you could go into Azure Functions. And then Azure Functions is a really true serverless solution that enables you to write code that's triggered based on one single event and that has 0 or more bindings to it. And then actually what you say is, okay, so I have this piece of code, and whenever a call on an API, for instance, comes in, run this code. And if you don't run it, I don't have to pay for it. And if you run it 10 million times, then my prices go up. But then again, I had the load to match the pricing. So with functions, you could have all different types of logic available that you write yourself, where you connect to different types of resources through configuration, which I will show later on. And then that enables you to be really, really fast with writing software and with getting it out there. And it also abstracts away a lot of the, for instance, resources that you connect to, because you leverage the power of the Azure platform that enables you to run logic apps, or sorry, Azure functions as soon as certain events come in.
Okay, let me share my screen before we start.
Sure. There we go.
Okay, as you know, this is Azure portal, and I want to create a function app. And it's asked me some questions, and I want to start with the publish options. There are two publish options here.
Yep.
First one is code, and other one is Docker container.
Yep.
So what is the difference between code and Docker container?
Well, the cool thing is that now that we have .NET 5 as an option also in functions, which we will talk about later, this changes a bit why those are different. But with the, let's say, classic, I mean, they are 5 years old and we're already talking about classic. But if you talk about classic functions, what happens is you have an ASP.NET sort of platform around your code that needs to run, and then it dynamically loads the assembly that holds your functions to be able to execute them. And that's when it runs on code, then you actually have the application that runs your assembly or loads your assembly and is able to run it. As soon as you go into Docker container, then you can specify your own Docker container to publish, to run your function app. And of course, that enables you to have a little bit more control over what's available in that container when you run it.
Okay, so I just select the code and select runtime stack.
Yep.
As .NET, and there are other options: Node.js, Python, Java, PowerShell core, and we can choose custom handler.
Yep.
Okay, the version is 3.1.
Yep.
And
that's actually already something weird, right? Because .NET 5 is not in there. And then the reason for this is up until .NET Core 3.1, the .NET runtime stack for functions was different from all the other runtimes. Because with .NET Core, as I said, they had this ASP.NET application that actually dynamically loaded your assembly holding your functions, and then it could be executed. But with .NET 5, information or the situation changed, because side-by-side installations with .NET 5 and .NET Core were different from having multiple .NET Core versions available. So what they actually did is they worked long and hard to now have a .NET 5 isolated worker, which means your function app is now an application that is being run by the Azure platform, and it adheres to a certain structure, of course, to be able to have the platform use the functions the way you would like them to be used. But now it has this own, let's say, custom handler. So it has a handler that enables you to run the application, which is a Azure Functions implementation. And the strange thing is that now .NET is more like the rest of the languages that support functions than it used to be, because it used to be a little bit special just being .NET with the ASP.NET runtime. And now it's actually a .NET 5 application that the platform uses a handler for to run your functions. So now almost all languages are virtually the same when it comes down to how they are run on the Azure environment.
Okay, thank you. So I go to the next one, hosting. Okay, ask for a storage account and operating system. And there is a plan type, and I want to ask about the different plan types, because we'll talk about serverless, but there's other options here. First one is consumption, like serverless, functions premium, and there is an app service plan. So what is the difference between these three?
Okay, so there's actually even more hosting plans, but they are not available when you create a new app, Azure Function app. The different types of hosting that you can have for your Azure Function are on an IoT Edge device, on Azure Stack. You can run it on Kubernetes, or you can run it on an app service, on a premium plan, or on a consumption plan. And then those last three are the most interesting ones. So consumption, premium, and app service, and those are also the ones that you have in that drop-down there. And then consumption is actually, as far as I'm concerned, the only true serverless solution, because it actually enables you to say, hey, here's my code. It runs with this trigger. It needs this bindings. And whenever somebody asks for it, so whenever somebody creates that trigger to actually run, go there and make sure that it runs. So then you don't specify anything with CPUs, with the amount of memory you should use. You don't have anything infrastructural to say about your application. The only thing you say is, hey, this code, when this event occurs, run it, and then it runs. So that's true serverless compute. Now, the nice thing about this is that if you don't have any code to run, or if you don't have any events that trigger your code to run, you don't pay anything. But there's even more cool stuff, because they also have a large free grant when you go in consumption plan. Now, first of all, I need to explain the difference between, or actually the terminology used for consumption plan. So we were used in the past to talk about number of CPUs, or number of cores, or number of gigabytes in memory, or IOPS for disk access. And those are all really well-known terms on performance, actually, or in resources and then performance. But Microsoft, as other cloud providers are more and more moving towards more abstract notions of performance. So for Azure Functions, they have come up with gigabyte seconds. And then gigabyte seconds is actually the amount of time your code runs, calculated in milliseconds, times the average memory load of your application in gigabytes. The first 400,000 gigabytes in a consumption plan are free each month. And then again, the first 1 million executions are free a month. So the pricing for consumption plan is twofold. On one hand, we have the number of executions, of which the first 1 million are for free. And then the second one is the number of gigabyte seconds you use, and the first 400,000 of those are free. Now, to give you a rough feel of what this means, I built a ordering website for my brother-in-law. He has 2 restaurants, and then COVID happened, so he couldn't have guests anymore. So we built a website for him to be able to have people order their food from their website. And then there's this function in the back that actually does payment handling, sending reports out, sending emails out, rechecking every, I think, 6 minutes to know for sure that there are no open payments that we are waiting for. And last year in 2020, we started out in March, and I ran that function app an entire year with all of that functionality for 11 euro cents. Now, that's, of course, not a heavy production load, since we're only in a local village here in the south of the Netherlands, but still 11 cents for an entire year. I mean, I could never do that with a ASP.NET Web API, for instance. Now, that's consumption plan. And then the second one that's interesting is the app service plan. So I think we all know app service plans as a way of running, for instance, an ASP.NET web application on Azure. And then with an app service plan, you can use the extra resources that you have available in that app service plan to run your function app. So for instance, if your website is not that busy and you still have an S1 or an S2 plan and there's some room available on the resources, you could run your function app as part of that app service. And then the cool thing is you've already paid for that app service, so you don't get any extra additional costs. The downside, you're bounded by the size of your app service plan. If your function gets very busy, your website might have issues, or the other way around, if you combine the two in one plan. And of course, if you need to massively scale, you don't have auto scale enabled, it will not scale beyond the confines of your app service plan, while on consumption, it'll just scale, I'm not going to say infinitely, but it will scale much more easily into large quantities. The last and very interesting plan is the premium plan. And then the premium plan is actually exactly that. It's a more enterprise targeted, maybe even plan, where it actually enables you to have features that aren't available in consumption plan, for instance, VNet access. So you can have your function app run inside of a VNet and then have your storage account also be part of that VNet, so that the storage account isn't internet accessible, but your function app can talk to it. And one very big difference between premium plan and consumption plan is also the fact that with the premium plan, you can have instances of your function already running, even though there's no load. Now, why is this interesting? If you run a function and it's ASP.NET, now with .NET 5, it's still .NET 5, but you can imagine if there's no load, because we can scale down to 0 if there's no load. If load comes in, your application needs to start up. And we all know that .NET has had a history of cold start times. So also with a function app, you can have somewhat of a cold start. And if you have a very fast increasing scale of load for your application, that cold start is not nice. So you can have a premium plan run pre-warmed instances. So for instance, if you don't have any load, I always want to have at least one instance of my application ready and available. If anything comes in, I can instantly handle it. And that eliminates cold start. But of course, that also gives you some extra costs, since you're moving into a solution in which your application is not only running when you need it, but it's always running so that you have it faster available. So that's what the premium plan is all about.
Okay, thank you. Let's continue where we left. So I select the consumption plan type, and the next one is monitoring. This is a standard option. I think all of the Azure services have application insights, and I don't want to select it for now because we are making a demo. Next one is text, and I think else is okay.
So while we wait for this deployment to run, one of the things that's also interesting to look at is the fact that you got this storage account ready and available as soon as you created the function app, right? Now, the reason that it does this is that by default, you get a lot of interesting information about when your functions were running, but also you could use, for instance, durable functions, which we will talk about later. And then it needs to store something of state somewhere. So by default, it always attaches to a storage account to enable you to have all of that dashboarding information. And while we are talking about this, I think about the fact that we forgot to talk about web jobs, because I did talk about Power Automate and Logic Apps and then functions, but web jobs is actually somewhere in between. Since in the beginning of Azure, before functions were a thing, they actually implemented web jobs as a form of, let's say, cron jobs that would run on the back end of your app service to enable you to, for instance, scan your database every night at 12, or send out an email to all new customers in a specific table, and then you would write that code yourself. That used to be in web jobs, which is a part of app service. Now you can still write web jobs. However, Azure Functions has, I think, progressed way, way, way further than web jobs was ever meant to go, into a complete serverless solution where you can also have all kinds of bindings with external systems coming in. So web jobs is primarily targeting cron jobs that we have on an application that runs in the background of an app service, while Azure Functions explicitly runs as soon as that specific trigger comes in. And I see that the creation of the function app was done by now.
Okay. Before your demo, I want to ask about development tools, because as a developer, it is very interesting for me to see development tools on Azure portal. So there are different development tools there, like console and extensions, AppService editor, and advanced tools. So do you want to talk about this one?
Sure. So first of all, console is actually something that looks a lot like the Azure CLI, but now you have a console that actually runs in the context of your app service. So if you want to look at files or do anything, look at the directory structure, or maybe you can do that here. So we can now see a host.json file that actually instructs the host on how to run this application. Then the advanced tools is actually something that's also available on app services. And if you click that button, you will notice that we go to a separate website. And this is actually, okay, I got to go one step back. When we create an app service or a function app, you get your app service name or your function name .azurewebsites.net as the default endpoint for it. But if you go your website or your app service name or your function app name .scm.azurewebsites.net, so you do SCM there in the middle, you'll get the advanced tools where we are right now. So if you look at the second tab, the Kudu services, you can see that it's Azure is Live, which was the name of the function app that you just created, .scm.azurewebsites.net, and this is actually running Kudu. And Kudu is an environment where you can see, like we see here, system info. But also, if we go to, I think it's under tools, we also have things available like the web jobs dashboard and the webhooks. And then this dashboard, once we have functions in place, will show us which functions are in place and when they were executed, and even their logging information. So this is actually something that runs out of process, out of your normal app service or your function app. And it gives you all types of interesting information about what's running on your app service or your function app in this case. And the fact that I'm saying app service or function app these many times together, it actually already tells us something that is very interesting to know. Azure Function Apps are currently a special form of an app service. Because if you go into app services now under your Azure portal, we will see this function app be listed under app services as well. And if you go to function apps, of course, we will only see the function apps of your subscription. But if we go app services, then this one will also be there, and then you can manage it from there as well. So that's actually quite the same. Now, the third thing that you asked me was the app service editor. And this is actually something that can go into a separate screen as well. And then this is the SCM that we just had. So Azure is live.scm.azurewebsites.net, and then it appends /dev to the URL. And here we see something that looks a lot like Visual Studio Code, right? So this is actually Visual Studio Code running in the browser, specifically targeting, in this case, an app service, where we see the listing of files on the left-hand side with the folders that they are under. And you can actually live edit stuff here as soon as your app service or your function app is up and running. You can live edit it here and see what the changes do with your application. So that's actually also pretty powerful. Now there's one more thing as far as tools goes that I would like to show here, because if we go to functions, and I think we should scroll down just a little, no, we should scroll up, sorry. So scroll up on the left-hand side, and then we have functions in place somewhere there. I think it's even further up. Yeah, there it is, under functions, that one, yes. So one cool thing that we have available here is the fact that we here have an add button on the top. And what we can do with this add button is we can actually add an Azure function in the portal without any developer tools on our local machine. We could say do an HTTP triggered function. So yeah, those are the options. So you can use any editor or VS Code or Visual Studio. But if you go into the middle of this thing that just popped up, you can see on template, yeah, choose the HTTP trigger one, because that's the one I'm going to be using later on. We'll do add. Then you'll give it a name, or apparently it already creates a name for you. And I think it might be triggered or trigger 01. Yeah. And then if we go to code and test, the cool thing here is that we can see an editor coming up that actually has something that looks a lot like C#, right? However, there's a few things that are different. And one of the most interesting things that's different is the fact that it uses #R to pull in Newtonsoft.json here. But also, the extension is .csx. Now, CSX is C# scripting. So this is they call it a scripting language that's based on C#. So you can write C# here. I think you even get IntelliSense, if I'm not mistaken. And then you can write your C# right here in the portal, or your C# script in this case. And if you click save, then you can automatically test that function out live on this function app. So we can, with this functionality, build our Azure functions in the portal without even having any developer tools running locally if we want to. Now I'm guessing it's going to say, that's connected. See, hello Azure, this HTTP triggered function executed successfully. Now if we look at the code, we can see that there's code in place that automatically checks if name is a query string parameter, and if it isn't, it checks the body to see if name is in there, and then it uses that parameter that you passed in to give an answer. So here we can see that we actually have a running function in the Azure environment without even having had any code on our machine locally.
No, that's great. Okay, so do you want to show something?
Yes. So let's switch to my screen. I see that I'm a little bit brighter right now because I have the light theme, because this tends to be a little bit better to work with as far as demos goes. So first of all, and I'm going to take off the very excess white stuff and only have this one available, which is my terminal window, of course. And then I'll go temp. No, temp, I said. And then I'll do make directory Mert to the future 001. Oh, it needs to be an M. And then go.
Can you please increase the font size?
Yeah. I was just thinking about that. So I have a different solution, which might be interesting. I will go right here. Come on. Sometimes this takes longer than you would like to. There we go. Now I'm thinking that this might help. There we go.
Yes.
This is better, right? So let's see, there's nothing in this folder, right? Now, the cool thing is with Azure Functions, we get Azure Functions core tools, which are local tools that we can run on our machine to develop Azure Functions. Now, without even using a development tool, I could say I would like a new version of a function. So I do func init, and init is initialization, of course, to make sure that we get a new version of a function up and we want to run it. So here I could choose the different languages. As you can see, it's skipping over all of the different versions. So for now, I'm going to do the .NET default one. At this point, it actually creates a CS proj in this folder to make sure that we have a functions project ready locally that we can start developing. And I do see that since the introduction of the .NET 5 runtime, it takes a little bit longer for the files to be created, but we can see we get the extra line over there. So right now, it's probably thinking, what am I doing? And then in a second or so, we will have a Azure Functions project locally on this machine. Normally, this is faster, and there might be an issue with the fact that I don't have my machine on power right now, so I'm going to do that in a minute or two. But what it's actually doing right now is so that's creating those files. So as we can see here, we have a VS Code folder. We have a gitignore file by default, a host.json that we also saw when you created that Azure Function app, local settings JSON, and a CS proj that enables us to do something. But as we see right now, we don't have a function yet. So I could say func new. So I would like to have a new function. And what I now get is a environment where I can choose the type of trigger that will trigger my function to run, right? So I could have it be a timer trigger. So for instance, every 5 minutes or every day on the 10th hour or every week. So I could specify a cron trigger that enables me to use this as a timer job. But for now, I would like to have an HTTP trigger. And the most important reason I would like to do that is the fact that you also created a HTTP triggered function in the Azure portal. So I would like to see what happens when we go there. Now, I'm going to call it triggered02. See that there's some blinking, so I might step out of zooming in. And as you can see now, it created triggered02. I'm going to zoom out now and make sure that we have the right folder open. So I go to temp and then mttf001, which is the folder that we just saw in the previous step. And it's actually creating that function right now. And I'm not really sure why it's so slow in running today, but apparently I have created something of a structure in my computer that makes that my function core tools run a bit slow today. But what it's doing now is it's creating an Azure function, a new Azure function under my Azure Functions project. And it's actually creating a file that's very much the same as the one that we saw when you created one in the Azure portal. So normally I can't talk fast enough to have this to be done when this is done, but now I have some extra time left. So what I will do already is I'm going to go into this folder and I'm going to ask to open it in Visual Studio Code so I can zoom out and use the zooming of Visual Studio Code itself. I'll open this up. And as we see here, I'll do this a little bit bigger right now. And as we can see right here, we have this CS proj available that says I'm a NetCore app 3.1, and it already pulls in a functions NuGet package that enables us to run this as a functions project. And then right now we can see here that we have triggered02, which is added as a function in this Azure Functions project. So just to get rid of all the red squiggly lines, which will jump in any minute now, I'll do a .NET restore. just to make sure that we have all of the packages that are external that we need to be able to run this. Now, what's interesting to see is the fact that this actually looks exactly the same as what you just created in the Azure portal, Mert, because this is a HTTP triggered function, and there the red squiggly line's gone. It created an HTTP triggered function, so this is the trigger for my function. It's an HTTP endpoint with a get verb, and in this case also a post, but I'm going to strip out the post right away because I don't need it. And then we have an HTTP request, and here we have that logic that says, okay, so if that thing is available on the query string, I'll get that name from there, and then I'll return hello with your name. Now, the way to run this really fast, or it used to be really fast, and I'm not really sure what you're going to do today, is I'll just do func start. Because I still have that Azure Functions core tools. I actually didn't do anything in Visual Studio Code, and I know that I did a .NET restore. However, I could have done that on the command line here as well. So we're running .NET or a func start right now, and what it's actually doing in the backend is it's building this project, and it's starting the Azure Functions runtime, and then it runs this function locally on my machine as it would in the cloud. So the nice thing about this is that I just have a Azure Functions app that runs locally on this machine, and it runs in the same way as it would on the Azure environment. But with this, I can just post or put breakpoints on locations where I want to see what happens to my code, and I can debug locally, or I can run into or against a local storage emulator, for instance, and make sure that I run my functions against the emulator, which holds the information that I need to have for testing. Now, what you see right here is that we have one function available. It's on the endpoint localhost 7071, which is always the default location for an Azure Functions API. And then the /API is automatically added. And in this case, it has triggered 02 since that's the name of the function. Now, the cool thing is, you can also change it here to be, for instance, name func. And now the URL would be localhost 7071 /API/name func. The reason why this is interesting is I will be showing that later on, but I'm going to zoom out for now, and I'm going to open up a new version of Edge and see if I can post that in with a name equals Azure-ish live. And then as we can see, I get the same result as you got from that Azure portal with hello Azure-ish live, this HTTP triggered function executed successfully. Now, there's more to show because this is running it from the, well, in this case, even the command line. So I'm going to stop the command line for now. And as you saw, we also have Visual Studio Code available here. So what I could do here is I could add a new function from here and start developing it from here. But of course, we also have Visual Studio, the full-fledged version available. So if I open a project right here, and I go into that folder that we just created, so that's C, temp, and then mttf001, and I have this CS proj here. Of course, this is a normal Visual Studio environment, so we can get all the extra stuff that we have available when we run on Azure, sorry, on a Visual Studio environment. The cool thing here is that you saw that that UI that you got in the portal for selecting the type of trigger for your function. And then we saw that type of UI in the CLI when we created a new function. And in Visual Studio, I can right-click the project, say add new Azure function, and we get again, I'm going to go into this. I'm going to say this is triggered 03. And again, I will get a UI that asks me what type of function would you be creating. So here I can say a timer trigger, and then I can set the schedule right here. So this means every minute divisible by 5, if I'm not mistaken, on the 0 second. Or a queue trigger, and then I can add the information for that queue trigger here. Or I can have that HTTP trigger that we saw earlier. I would like to have this on anonymous. And then as soon as I add this, and I hope in Visual Studio it'll be faster than when I run it locally from the CLI, but I also see a white bar of not responding on this one. So then we go into this function, and again, we get that same blueprint of an HTTP triggered function with a get endpoint and a post in this case that runs that name thing. So all of these are actually relatively the same UI to get to the same end result, but you can do it from the Azure portal, you can do it from command line, you can do it from Visual Studio Code, or in Visual Studio, in this case Enterprise. All of them are very similar. So the development, as far as that goes, is very nice. It's very recognizable. And then the cool thing is, if we put a breakpoint here and we just say run, then of course, like we are well known with Visual Studio right now, it will automatically start up the Azure Functions core tools. It will automatically start up the storage emulator if it doesn't run locally. See, it's starting the Azure Storage Emulator right now. And then it will automatically run Azure Functions. And as soon as somebody hits this endpoint, I will get a normal breakpoint experience as I always have it. So let's see if that happens. Because if I now go into that edge thing once again, and I think I called this triggered 3, right? And the name equals blah. I call it triggered. Oh, I did a typo. I had triggered. I'm not really sure what I typed there, but apparently this one. And as you can see, we now hit the breakpoint, and we can see the HTTP request coming in. And this has all of the different types of information that we need. So we can use this and run from here. So that's about development tools for Azure Functions. I'm going to get this one out really quick because I thought I had everything in place, but I need this one extra thing to give me some juice to enable me to keep running. There we go. So these are developer tools for Azure Functions. Now, I want to show something else that's, as far as I'm concerned, pretty cool. And I'm going to open up a repository that I've been using for quite some time now for different types of talks that I gave about Azure Functions. And this is actually available on GitHub. So if you go to my GitHub page, it's not that complex, but it does have some interesting information in there. So if I go to my profile, and I'll boost it a bit, one of the things that you can see here is functions, triggers, bindings example, this one. And this actually gives you a lot of insight into the cool stuff that you can do actually when running Azure Functions. Because again, Azure Functions isn't only a serverless compute solution. It doesn't only abstract away the infrastructure that you need to run your code. It also abstracts away the resources that you connect to. Now, let me give you a small example of what I mean. Let's go into this one, the most simple one of all. This actually says, I would like this function to run every time something happens on a specific location in my blob storage. So we have a storage account connected to our Azure function. And in this case, I say, as soon as a file comes into the upload container, that's the name that I specify here inside of the blob trigger, every time a file is created here with a specific name, and look at the fact that this is in curly brackets, with a specific name, I would like this function to activate, to start working. And then what we actually have right here is we already get the blob that was added as a parameter in our Azure function, right, available to start working with. Now, if we wanted to have this with the, what was it called, directory checker, or there was a name for this, the directory watcher, the file watcher, way back when, this would have been a lot of work. But now I can just specify, okay, so if a new file comes in this upload container, bind it to this blob for me or to this stream, and I would like to talk to it. But there's more, because there's also a name right here. And that name is the name of any file that's created in that upload container, but now it's automatically populating this name parameter since they are the same. So I'm saying each file in this upload container that has a name, take out that name, put that name in this variable or in this parameter, and automatically bind this stream to be pointing towards that new file that was just created, and now I would like to do something with it. So what we're doing here in code is relatively straightforward. We get the connection string from the settings, and then we create a storage account, and then we create a blob client for that storage account, and then we create a container for that blob client. Then I would like to create that container if it doesn't exist, because I don't want my code to fail. And then I would like to get a reference for a blob with the name of the added file in the upload container, and I would like to copy the file that was just uploaded into this copied container. Now this is 2, 4, 6, 7 lines of code, and these 7 lines of code automatically copy a blob from one location to the other each time a new blob is created. And of course, this is not really very interesting code, but this could also be resizing an image that comes into an upload folder each and every time, or checking it for adult content before we can post it on a public website, or we could do a lot of things with this. Now, this is already relatively straightforward, as I said, but with the power of Azure Functions and the power of bindings, we can eliminate a lot of code that's currently in here. Because if we use this second Azure function, this does the same thing with only one line of code. Now, the way this works is I again specify that I would like to have a trigger for a specific blob when a new file is created in the upload container, and then I would like to bind it to this stream parameter. However, I'm also saying I would like to have a binding to a blob in the copied container with the same name as the file that was just uploaded, and I would like to have write access to that file. Bind that to that stream, to a stream as well, to a stream parameter, and then all I have to say is I would like to copy the stream that was just added into the stream that I would like to copy to, and the platform takes care of all the rest. The platform takes care of taking that connection string out of settings, because you specify the name of the setting that you would like to use here, and the platform takes it out for you. And then you want to have a container reference to the copied container, the platform does that for you, and it even creates it for you if it doesn't exist. And then it creates a blob with the specified name of the same blob that was already uploaded in that upload container. And it all binds that to this stream. And the only thing you as a developer have to do in this point is the actual action that you wanted to do. Now, I could go on and on about this, but there's only one thing that I would like to talk about for now, about bindings, that is. And that's the fact that right here we can see again the HTTP triggered function, right? We have a API endpoint that we can talk to, and then our function runs as soon as that API endpoint is talked to or connected to. But then instead of the HTTP request that we used to have in our previous Azure functions that were HTTP triggered, I now have this custom model. And that custom model is actually just really a class that I defined in this project with a name, a date of birth, and an identifier. And I can ask the runtime, okay, so when a post on this endpoint comes in, auto deserialize the body for me into this some custom model, because I know that anybody who's going to talk against this endpoint will be sending over this model. And it auto deserializes for me, so I don't have to read the body of the request. I don't have to deserialize it with Newtonsoft or system.txt.json. I can just ask the platform, deserialize this for me. And then inside of that model, I have this thing that's called an identifier. And that's a globally unique identifier in this case. And then there's some magic happening here where we say that binding for a blob that we want to talk to based on this event that just happened, I would like to get the identifier from the model that was triggering my action and take that identifier and let that be the name of the blob that I'm actually going to create. So these two lines of configuration, as I think we should call them, automatically provides us with an API endpoint that we can talk to, that connects or that accepts post requests, that automatically deserializes the body into a specific custom model, and it automatically creates a file in the properties container of our storage account with the name of the value of the identifier from that custom model that we just deserialized, .txt, and we get write access to the stream that was bound and automatically added or inserted into our Azure Functions method in this case. And then all we need to do is write into that stream and we get a blob that actually has the information. Now there's not tons, but there's a lot of different types of bindings available. Let me check real quick to see if I have them right here. Now I'm not really sure if my machine will allow me to do this. It seems like it does. And then as you can see here, this is actually a relatively old slide. So probably there's some new versions available. But what we can see here, and I'll take my laser pointer, what we can see here is that we have, for instance, the possibility to trigger on blob storage, but we also have the possibility to trigger, for instance, on an event hub or on an IoT hub, or we could have an input binding out of Azure Cosmos DB, but of course, there's always more. So we can also trigger based on SendGrid or stuff that comes from Service Bus, or we can have table storage be connected to our Azure Functions. And all of these different types of triggers and bindings are available by default when you run an Azure function, enabling you to be very fast and very, you have a very small time to market if you actually want to start building APIs or event-driven architectures using Azure Functions.
Okay, thank you for the demo. And let me ask in a different way, what makes an Azure function durable?
Yeah, what makes an Azure function durable? Okay, so one thing that we haven't talked about yet, which is intended, is the fact that on the consumption plan, your function needs to finish within 5 minutes. That's the default setting. You can up that to 10 minutes, but it needs to finish fast. And the reason for this is they host this application for you probably somewhere on extra resources that they have available. So it needs to be short-lived so that if they need the resources back for the people that actually need them, they want to give it back to them. So on consumption plan, by default, your function needs to finish within 5 minutes. If you don't, it gets killed. They don't ask you nicely, they just stop the process after 5 minutes. So that's something that we need to take into account. Now, with running on an app service plan or running on premium, you get different types of timeouts available. But still, the general idea of Azure Functions is to have them be short-lived, fast action, and of course they can run a minute or two, but they shouldn't run any longer. Now, sometimes you have actions that just take a little time. You gotta maybe have one function that calls another, that calls another, that calls another, that calls another. That's called function chaining. Or maybe you have this bulk load of data that you would like to fan out over 10,000 instances of Azure Functions and have all of them calculate their own results and then come back together, which is the fan out, fan in design pattern for functions. Or maybe you have something that you need to wait for externally, like an API, or maybe even manual approval by a manager, for instance. Now, what they did with with Azure Durable Functions is it's an extension on Azure Functions that enables you to implement all of these types of patterns. And if we go to the Azure Durable Functions website, I'm going to see real quick if I can get it up right here. So I'll just do Azure Durable Functions, and then we'll probably have the first hit. Now, if you look here, here's, for instance, function chaining, right? You have function one and the result of function 1 needs to go into function 2, and then the result of that one goes into 3, and the result of that one goes into 4. And these might not all work within 5 minutes. And then you have fan out, fan in that I just talked about, where you want to split out the work and have it run over multiple instances and then come back to one generic solution. Or we can have an async HTTP API, so an external API that we need to wait for to be ready. Or we can monitor something, so that's a flexible recurring process in a workflow. Or again, human interaction, where we could have somebody that needs to make a check or and accept something or not accept something, or approve or not approve. And then we want to handle that one. What they did with durable functions, again, an extension on the Azure Functions environment, is implement a way where they have all of these different patterns, and then they store the state of your application as soon as it goes into something that might take a while. So they actually build something that looks like a state machine, and then they say, let's go to the function chaining to have it be the simplest thing to explain. So let's say they go to function 1, and function 1 runs, and when function 1 is done running, it might have a specific state, and then it stores that state, and then it goes on to function 2. The cool thing is, if your function is depending on external information, or if you want to wait for function 2 to finish before starting function 3, what they actually do is they store the state of each of the different steps of your orchestration. And people who used to do BizTalk might know orchestrations, and orchestrations are those very big visible things that you use to drag and drop actions around, and then that was your way of actually running through the different steps in a orchestration in that case. And what they do here is very much similar to what they used to do in BizTalk, because what they do is, as soon as they have a specific state that they need to store and wait for the next step in the orchestration to run, they do something that they call dehydrating, or they actually persist the entire state of the application into a storage environment. And then as soon as the external trigger that we need to continue running our process comes in, it rehydrates the entire state. And then it looks, okay, so I had 5 things to do. Step 1, yes, I have a result for that one, so that's done. Step 2, yes, I have a result for that one, so I don't have to call that one again. Step 3, I don't have a result state, an end state for this step. So apparently that's where I left off, and then it will continue working from there. So with the durable functions runtime, or the durable functions extension, you can write stateful functions that enable you to have these different types of patterns in your application. And as you can see right here, it looks very similar to what we just created for, let's say, normal Azure functions. But in this case, we have an orchestration trigger. And then we say, okay, I want to run function 1. And if that's done and the result goes into X, I want to feed X into function 2. The result of that is Y. I want to feed Y into function 3. The result is Z. And then I'll feed Z into function 4. And then we're done. Well, all of the different types of patterns that we saw have similar but different implementations. But in the end, it comes down to a durable state of your Azure function throughout different steps in that orchestration that needs to run.
Okay, thank you. So before jumping to the best practices, let's get back to my portal. And there are some options that are in preview, for example, events.
Yep.
So what are events? How can we use it with Azure Functions?
Yeah, as far as I'm concerned, events are awesome. And I think they are really a not so well-known feature of the Azure environment. And what this actually is Azure Event Grid. And Event Grid makes events a first-class citizen in the Azure environment. And an event can be anything. So, for instance, a new blob was created in your storage account. That could be an event, and then it triggers your application to run. But it can also be a new VM was created under your subscription, or somebody put a file in an AWS container somewhere. And the reason I'm explicitly saying AWS or Google Cloud Platform or any other big cloud is the fact that Event Grid is an eventing mechanism inside of Azure that enables you to do and handle events. But they don't only accept Azure events, they even implemented the cloud agnostic standard called Cloud Events, which means that your event grid can also hold AWS events or Google Cloud Platform events or any other cloud providers' events if they adhere to the open standard. Now, the nice thing about events is the fact that it's instant. And as we saw with the blob trigger that I just showed you in the environment or in the Visual Studio, in a consumption plan, that can take up to 10 minutes to actually trigger your function. And the reason for that is that there's a lot of optimization around the both the functions environment and the storage environment, which makes that sometimes it might take a little time before storage actually persists its new metadata. And then it might also take a little bit of time for your function app to see that the metadata was changed, because in the end, it's still a sort of a polling mechanism. However, with the trigger that we have in the Visual Studio or in our functions app, the polling is done for us. But in the end, it's still polling. So that can take up to 10 minutes for instance, a blob trigger. Now with this events right here, this is instant and actually really instant. So the cool thing with Azure Event Grid and with events that are here under preview under this function app is that you can, as you see right here, automatically trigger based on a storage queue, based on an event hub, based on something that runs in a storage account. There's a lot of different triggers, events that can happen that can trigger your application to run. And in this case, that would be an Azure function. Last thing about events is the fact that you can write your own custom event, which means part A of your application, for instance, automatically creates a customer in a table, and it could also emit an event customer created. And instantly, another part of your application, somewhere in a completely different environment of your Azure environment, says, hey, I get an event that a customer was created, so now I can send out a welcome email. And that means that you can have eventing that we used to have within one system, but now on a cloud scale, which means we can have several types of, or several parts of our application running across Azure or maybe even multi-cloud, and we can have an event triggering the handling of that specific event based on what happened either within your Azure environment or another cloud provider, or within your own application if you're building custom events.
Okay, thank you. And other preview option is App Source Editor. We already have gone through it.
Yeah. That's the Visual Studio in the cloud or in the browser option. So that used to have a different name, right? Was that project?
Yeah.
I'm not really sure what it was called.
We can see our HTTP trigger.
Yeah.
They code here and function JSON. So the last one is the diagnostic settings.
Yeah, and that's actually a new preview that they enabled to have different types of diagnostic settings to configure the collection of different types of data. Because by default, of course, I think you don't want to store everything. But if you're in a certain scenario where stuff happens that's rather strange or you can't explain or there's errors, then of course these diagnostics would enable you to see what's happening even better. Although, as far as I'm concerned, Application Insights is already a very, very, very powerful way of seeing what's happening in your environment.
Okay, I think we have forgotten to talk about extensions.
Yeah, extensions actually something that's the same as extensions under an app service in Azure. And for instance, I think Application Insights is in there as an extension as well. But what I use, for instance, is one of the extensions. But then it's, to be honest, it's on an app service. But there's this extension that enables you to do Let's Encrypt certificate management completely using functions as a backend. So I think, I'm not really sure. That's the Azure Let's Encrypt from SJKP. SJKP. He actually has the entire source available on GitHub as well. But for instance, this is an extension that enables you to configure everything that you need to configure around Let's Encrypt and just have a function run every day. And if your certificate is about to expire within 30 days, it will automatically do a new request or a request for a new certificate over at Let's Encrypt, get the certificate, install it in location, and then you're good to go for another 90 days. So there's a lot of extensions which are actually from external providers that you can add to your app service or function app in this case.
Okay, thank you very much. So I want to ask about the best practices, any common mistakes or any challenges maybe face while implementing the Azure functions.
Yeah, so that's actually a good question. One of the things that's really important is the fact that they need to be short-lived. And Azure functions are really meant to be fast. Now, initially, that was reason for Microsoft to not add dependency injection to Azure functions, because they said you don't want to build up this entire dependency graph or service collector with all different types of services, because you want to have them quick and fast. However, with the introduction of Premium Plan and with the possibility of running it on an app service, and the fact that DI is getting more and more into swing, they eventually started using DI in Azure functions as well. So if you could maybe share my screen just a little bit more, I can show how that works. So if we look at this, this is a, let's say, normal Azure function. It's HTTP triggered. It doesn't have anything specific except for it has a new greeter service, and then we call hello, or we call greet on that greeter service. But of course, new is glue. So we don't want to new this up here. Now, I'm going to keep this open, and then I'm going to add this one and make sure that it's on the side of it. And I think Visual Studio might be able to help. Now, there's one thing that's very different about these two, and it's not the fact that we're using the greeter service injected, but the first thing that I want to address is the fact that by default, a class containing an Azure function is static. And then by default, the Azure function itself is also static. However, with DI coming in, we lose the static class and the static method, because we need to have a constructor in which our dependencies can be injected. So our functions and our function holding class cannot be static anymore. So what we did, or what they did, and what we implement is we get a startup class. And let's do this real quick. No, I'll just close that one down. I have the entire screen. We get this startup class, and then we inherit from functions startup something that's under Microsoft Azure Functions Extensions Dependency Injection. We get this functions startup, and then over here we have this assembly attribute where we say, for the functions startup of this assembly, look at the startup class. That's where the function startup is. And then we get an configure that we can override that actually gets in the iFunctions host builder. And then we can, just like we can in ASP.NET, add services to our services collection. And in this case, we add the iGreeter service implemented by Greeter service on the iFunctions host builder iService collection. So when you start running this or implementing this, you have this constructor for greet02 that actually injects iGreeter service into the constructor. We store that in the local field greeter service, and then in our function, as soon as it's called, the only thing we need to do is call greet on that greeter service, and we're done. So this is something that's important as far as I'm concerned. use dependency injection, but also be sure to not have it become too big. Now, another thing that's really interesting is the one that I have here, because what I think is very powerful is table storage. And table storage is a part of storage accounts, but we also have a table storage API on Cosmos DB, and it's actually a NoSQL solution, right? So we have a NoSQL solution that's really easy to have very fast entities in a table. Now, what I did here is really straightforward. We created a table entity called tent, and then it has an ID, a name, and a description. Okay. The reason I'm showing this is that we can have input bindings also for table storage. So the one thing that I actually want to highlight right now is the fact that these bindings, so these triggers and these bindings, are really, really, really powerful. What happens here is purely based on the fact that I have a table binding that binds to the table with the name tent in this case. I would like to get a cloud table that enables me to talk to that table storage in that storage account or in that Cosmos DB and get entities from there and just give it back. And we can even go a little bit further, because I'm going to go into that other project that I had somewhere. Okay, no, that's that one. That's that one. Okay, I'm going to go open project. I wanted to do project solution. I'm so sorry. Open project solution. Again, this is also under GitHub. So we'll go code, we'll go GitHub, and then we'll go functions, triggers, bindings, example. Take that one. This one. Because what we see here is even more power of that same table storage binding, because here we have an entity that's called SomeEntity. So we do this to the table SomeEntity. But in this binding here, we can specify a partition key and a row key to uniquely identify one specific entity from that table that we want to have based on what comes in on our API endpoint. So if we specify the route to be smart enough to say /API/entities, and then somebody can provide us with a row key, we can have that row key be used right here in the row key parameter for the table binding, which means these two lines of configuration automatically give us an API endpoint that we can call with a GET request on the route API/entities/ and then any row key that is a valid row key, and we get a specific entity of type SomeEntity back based on the partition key and row key that was extracted from our URL. So the platform here actually does everything for us to give us the right entity that we actually want to target right now. So that one entity within that one partition with that specific row key. And the only thing we need to do is return the entity that we just got back from our bindings. So in other words, this is a GET endpoint for an API for one specific entity with actually 0 lines of code. Yeah, we return a new OK object result because of the power of bindings and triggers. And that's why I think it's really important to have a look at what are you trying to do and how can you uniquely and as fast as possible use triggers and bindings to make sure that you can get to the end result that you actually want to get to. Now, there's a ton more that I could talk about, but I'm not really sure if we have time for that one. I do have one final thing on best practices, and that's the fact that we all know, or maybe, I think most of us know Vercel as a hosting provider or Netlify. Well, Microsoft Azure now has Azure Static Web Apps, which is a solution where you can have your static front end, so Angular or React or Blazor WebAssembly or anything that doesn't need a server backend, and host it in a static web app. And then you can write Azure functions to be the API backing that website. And you can have everything be in one place and ready and available on the cloud. So without having to specify that all of that, I'm going to go to my website, rickvandenbos.net. You can also, let's zoom in a bit. You can also say Rick VD Bosch and then have a dot there between the S and the CH, because then we'll go to the same website. And then what I would like to show here is that under blog, we have static website, a first look, Azure Static Web Apps, quirks and gotchas, Azure Static Web Apps, an update. And here I actually completely explain what an Azure Static website is and how it actually works. But the cool thing is that if we now go to Azure Static Web App, so in the browser, aswa.rickvandenbos.net, we go to a web application, and maybe you saw it, and I'm going to F5 once again. You can see that this is coming in a little bit late. So what this is a Angular front-end application that talks to an API in the backend that's being implemented by Azure Functions, and it's completely hosted inside one Azure Static Web App, and it's fast and it works. So as far as static web front ends with APIs you would like to talk against in the backend go, please have a look at Azure Static Web Apps. That's one thing that I needed to sneak in there.
Okay, thank you very much. And this is a great start for my new show, Mert to the Future. And thank you very much for joining me this evening.
No problem. Thank you for having me.
You're welcome. Hope to see you in further episodes. Maybe we can talk about the other features of Azure Functions or other Azure resources.
Yeah, I still have a ton of things to tell, even about Azure Functions, or we could, I think, do an entire show on everything that .NET 5 brings to Azure Functions with the isolated process and how that works. And then I also have something to say about security and configuration. So I would love to come back to your show somewhere in the future.
Okay, thank you very much.
Thanks.
See you. Cheers.